Welcome to today's GATE video. Myself Sindhuja, Assistant Professor, Department of Computer Science Engineering from S.A. Engineering College. In today's session, we are going to discuss trees in data structure. Okay, before we get into trees, okay, we are going to look into the overview of these topics. First, we are going to see what is data structure, types of data structure, tree, types of tree, and some few GATE questions on tree. First, let's see what is data. A data is a collection of facts, figure, concepts, occurrence, observation, instruction in a formalized way. And in the other way, in an easy form, we can say a data is a collection of information. Data is a collection of information. So information is a collection of files. So again, what is file? File is a collection of record. And again, what is record? Record is a collection of related fields. So these are all a collection of information. So a data can be expressed in a different way. So the data exists in various forms, including a number, text, image, audio, or a video file. So a data can be in any type of data, which means a number, audio, video, animations, or a text format, or any type of data. We call it as an information or a data. Okay, let's see what is data structure. So data structure, it is a way of storing and organizing data in a computer memory so that whenever it is needed, we can able to access and retrieve the information efficiently. So here I just gave the example, a real-time example for data structure is library. Okay, let us take a central library. In a library, we have lot of books. We consider each and every book as a data. So here we have a collection of books. All the books are arranged and organized in a special way so that we can able to access the book efficiently. So similarly, in data structure also, the data are arranged and organized in such a way so that whenever it is needed, we can able to access and retrieve the information efficiently. Okay, let's see the types of data structure. Data structure, we have two different types of data structure. One is linear data structure, other one is non-linear data structure. In linear data structure, okay, we say from the name itself we can say linear data structure. What does it mean? Okay, the data has been arranged in a linear way, which means the data follows certain pattern or a sequence. So that is called a linear data structure. Array, stack, queue, linked list, all these things comes under linear data structure. Whereas in non-linear data structure, again, an opposite to linear data structure. The data is not at all arranged in a proper way. In the other word, the data does not follow any pattern or sequence. So that is non-linear data structure. Here we have graphs and trees. So these all comes under non-linear data structure. Okay, let's see what is linear data structure. As I told you earlier, so all the data elements are arranged in a sequence or a pattern. So here we have array, stack, queue, and linked list. Okay, array. What do you mean by array? Array is a collection of similar data type. And next, and what is stack? Okay, stack, it follow last and first out property. And queue, a queue follow first and first out property. And last is linked list. Okay, although we have array, stack, and queue, why we go for linked list is in the above array, stack, and queue, insertion or deletion of data is not at all happening in a proper way or not happening in efficiently. So that's why we go for a linked list. In a linked list where you have a data path and an address path. In data path you have an original data, and whereas in address path you have address of next data. Okay, again we comes to non-linear data structure. The in data structure where data elements are not arranged in a sequence or it does not follow any sequence or pattern, that is non-linear data structure. We have tree and graph that comes under non-linear data structure. So tree is not arranged in a proper way or it does not follow any pattern or a sequence. Similarly, graph also does not follow any pattern or sequence. So these two comes under non-linear data structure. So let's see tree in detail. A tree, a data structure, consists of various nodes linked together. So these are all nodes, A, B, C, D, E, F, so till H, these are all nodes. Okay, so all these nodes are connected through a link. This link we call it as edge. So the top node we call it as a root node, otherwise we call it as a parent node, and and almost the corner of the node, or in the other way we say at the end of the or edge of the node, we say it as a child node or a leaf node. So here also you will be having different types of trees. You have AVL tree, binary tree, and binary search tree. Okay, let's see what is AVL tree. AVL tree is also a binary tree. So it follows a self-balanced binary search tree. Okay, so here the binary tree is balanced way. So the left side of the node and the right side of the node will follow the same level. So that is called self-balanced binary search tree. Okay, here the average time complexity of the AVL tree is order of log n. So for searching, insertion and deletion operation. And next we'll see what is binary tree. Okay, a binary tree is a type of tree data structure where each node can have maximum of 2 children. Okay, so here a binary tree it should not exceed or it should not have more than 2 children. So that is called a binary tree. At most it should have only 2 children. Okay, that is called binary tree. Okay, in the other word we can say a node should have a left node and a right node. So that is called a binary tree. Next comes to binary search tree. A binary search tree is a binary tree. Okay, first it has to satisfy the binary tree. Okay, again, so every node of the left child has lower value and every node of right child has a higher value. See, we have a root node. Okay, let's consider the root node. Okay, so in root node, the root node of a binary tree. Okay, here what happens, the left side of the root node should be lesser than the root, whereas the right side of the node should be greater than the root. Okay, so here I'll repeat one more time. The left side of the node should be lesser than the root node. The same way the right side of the node should be greater than the root node. So this is called binary search tree. Okay, here we'll see representations of binary tree. Okay, so for any node n, okay, for any node n, to find left child we have to follow this formula 2 into n plus 1. So to find the left child or to find the left node, you have to use the formula 2 into n plus 1. Similarly, to find the right child, we have to use 2 into n plus 2. And to find the parent node, okay, we have a formula n minus 1 by 2. So these are all the formula. By applying this formula, we can able to find the left child, right child, and also a parent node. And next is tree traversal. How the trees have been traveling, okay, from the top to bottom or bottom to top. Okay, how the tree has been traveling. Okay, we are going to see. So here it is classified into pre-order traversal, in-order traversal, and post-order traversal. Okay, in pre-order traversal, okay, we have a pattern like, or we have a formula like a root, left and right. Okay, let us consider left and right. Okay, before left and right, root will be there. That is pre-order. Okay, before left and right, root will be there. That is pre-order. And in order, okay, in between left and right, root will be there. That is in order, in between. Okay, just note down. So in between left and right, you will be having a root node. That is called in order. Post order means, okay, left and right. Okay, after that only you will be having root. Okay, post order, left and right will be there. After that only you will be having a root node. Okay, so pre-order traversal, in-order traversal, and post-order traversal. Okay, let's see a gate video. So in gate video, we'll be having a gate questions now. Okay, so the first question is, the pre-order traversal of a binary search tree is 15, 10, 12, 11, 20, 18, 16, 19. So these are all the values they have given. Which one of the following is the post-order traversal of the tree? Okay, we have to find which one of the following is follow the post-order. Okay, first let us draw the tree for it. Okay, first let's draw tree now. Okay, let us consider this data. 15, 10, 12, 11, 20, 18, 16 and 19. First we are going to draw the tree for it. Okay, the first will be 15. Okay, a node 15 we are going to take it. Okay, fine. First, as I told earlier, a binary search tree, in binary search tree, left side of the node should be lesser than the root node and right side of the node should be greater than the root node. So this is the root node. Okay, so 10. Okay, 10 is lesser than 15, so it has to come in the left. Okay, again 12. 12 is greater than 10, so it has to come right. And 11. 11 is also lesser than 12, so it comes here. And 20. Okay, 20 is greater than 15, so it is greater than root node, so it has to come right. Okay, again 18. 18 is lesser than 20, so it comes left. And 16. 16 also lesser than 18, so again it comes left. And 19. 19 is greater than 18, so it comes right. Now we are going to find post order. Okay, by using the formula you can able to find the post order, but here we have a small trick here. Okay, for in order, okay, we have a flag. We can set a flag like this in left side for pre-order. For in order you can set the flag in the middle, and for post order we can fix the flag in the right side direction. So in this way you can easily able to find the post order traversal. So here we are going to find post order. So for each and every node we are going to set a flag. Okay, right side. So now we are going to travel from the root node. So we are going to touch each and every node. So wherever the arrow, wherever the flag touches, we'll be getting the post order. So let's come like this. So here it touch in the 11. Again it touch in 12. Again it touch in 10. Again it just come back. Again it touch 16. Again it touch 19. Again it touch 18. From 18 to 20. From 20 to 15. It reached the node. So let's check the answer. 11, 12, 10, 16, 19, 18, 20 and 15. So option C is the correct answer. So in this way we can able to find the traversal easily. Okay. Okay, the second question, how many distinct binary search tree can be created out of 4 distinct keys? Okay, so this question asked in 2005. Okay, before 2005 they have asked instead of 3 distinct values. Okay, instead of 4 distinct values, they have used 3 distinct values. Okay, so let's take that example and then we'll look into value 4. So they were asking what are the possible tree structure with the help of 4 keys. Now we'll take an example using 3 keys. Okay, so it's 3 nodes. This is one way. This is second way. This is third way. This is fourth way. And this is fifth way. So these are all the 5 possibilities. Okay, using 3 distinct keys. Okay, now we are going to find for 4 distinct keys. Okay, here instead of drawing a tree diagram, we are going to use the formula here. So using this formula we can able to get the answer easily. 2n c to the power of n divided by n plus 1. So by applying this formula we can able to get the answer. For 3 distinct keys the answer is 5. but for 4 distinct keys, so the answer won't be 5. It should be greater than 5 only. Okay, let's apply the formula. Instead of n, we are going to replace as 4. We are applying this formula. 2 into 4cn, that is 4c4 by okay, these get cancelled, and again 4 into 3 into 2 into 1, so this can be replaced as like this. So 4 2s are 8, 3 2s are 6, again these 2 get cancelled, then the remaining is 2 into 7, so 2 into 7 is 14. So 14 is the answer. Option B, 14 is the answer. So instead of drawing trees, okay, we can simply just apply this formula and we can able to find the answer. Okay, next gate question. Suppose we have numbers between 1 and 100 in a binary search tree and want to search for a number 55. So we have numbers from 1 to 100. We want to find number 55. Which of the following sequence cannot be the sequence of the node examined? So this should not. So they are asking which cannot be a sequence. Okay, remaining and all sequence, that one is not a sequence. So let's see one by one. Okay. Okay, let's take an example 10. Okay, 10. Okay, we are going to draw tree now. So the next value is 75. So 75 is greater than 10, so it comes right hand side. Okay, next 64. 64 is lesser than 75, so it comes left hand side. And 43. Again 43 lesser than 64, so 43 comes here, and then 60 also, 60, okay, 60 also greater than 30, 43, so it comes in the right hand side. And next 57 is lesser than 60, it comes left hand side. And 55 also lesser than 57, so it comes left hand side. So it just follow a sequence. So this is option A. Okay, let's draw for option B. Okay, first is 90. It starts from 90. Okay, 90. Okay, 12 is lesser than 90, so it comes left hand side. And 68 is greater than 12, so it comes right hand side. And 34 is less than 68, so again it comes left hand side. Then 62, okay, it is greater than 34, so it comes right hand side. 45 lesser than 62, left hand side, it comes left hand side. Again 55 is greater than 45, it comes right hand side. So this is also follow a sequence. Let's see third option, 9. Okay, 9. The next value is 85. So 85 is greater than 9, so right hand side. 47 lesser, so left hand side. 68, okay, is greater than 47, so right hand side. Then 43 here. Okay, but 40 has to be come here. But what happened? It has to be, but as in the question, okay, as in the option, it has to come here. Oh, but this is not a sequence. Okay, it has to come here, but it doesn't follow a sequence here. Okay, so this is the answer. So let's see the option and just fix the answer. So the root node is 79. So 14 is lesser than 79, so left hand side, and 72 is greater than 14, so right hand side, and 56 lesser than 72, so left hand side, and 16 lesser than 56, again we are going to place in left hand side, and 53 is greater than 16, so you are placing in the right hand side. 55, again it is greater than 53, we are placing in the right hand side. So the D option also follow a sequence, B is also following a sequence, A is also following a sequence, D is also following the sequence. Okay, which one is not following the sequence is C. So option C is the answer for this. Okay, the next question. Okay, it has been asked in 2016. The question is, consider the following new order strategy for traversing a binary tree. Okay, visit the root. Okay, they have given the condition in which order you have to follow the tree. In which order the tree has to travel. Okay, first is visit the root. First it has to visit the root. Then visit the right subtree using new order. Next visit the left subtree using new order. So the order they have given is 3, 4, and then so these are the following order. So this is the following sequence they have given. So let us see. First let us make a tree, or let us form a tree, and then we can able to travel in this order. So this is the question. So first we are going to use this stack and we are going to draw tree. First we are going to push 3 here. So the first value we are going to push here 3, and after 3 we are going to push 4. Then after 4 you have a symbol, multiplication symbol, star. So after getting this we have to start a drawing tree. So 3 into 4. So this form a tree. So after that what happened? So 3 into 4 is 12. So 12 is the answer. With this 12, what we are going to push? 5. Okay, we are going to push 5. After pushing 5, again we are going to push minus. Okay, so again we are going to follow. Again we are going to form a tree again. So here minus 5. So already we have 12. 4 3s are 12. Okay, here 5. So you get minus. So after doing operations, okay, after doing subtraction, we get 7 is the answer. Okay, so this is the 7 is the answer so far. Then after 7, what we are going to do is, till minus we have pushed. After 7 we are going to push the value 2, and then after 2 we are going to push the power symbol. So here we are going to convert this into a tree now. So already we got 7 here. From this we are going to push. Okay, so we pushed all the elements and then we got the tree so far like this. After this, okay, we are going to push 6. Okay, let's start here. We are going to continue from this, continue with this value. Okay, okay, after 7 we are going to push 6. After 6 we are going to push 7. After 7 we are going to multiply here. So what we are going to multiply here? We are going to multiply 6 with 7. So that is not match with this tree. So we are going to draw a separate tree here. So 6 and 7 got multiplied. So for this we got just draw the tree here, and after that we are going to push value 1. Okay, after that 1 we are going to push plus. Okay, so you are going to add with this element with 1. Then finally you are going to subtract these two trees. Okay, so this is the tree structure we got from this expression. Okay, so let us see the correct answer. Let us find out the correct answer. Which one comes first? So for finding the answer, we have to follow these steps. Okay, first we have to visit the root node. So this is the root node. Okay, so the answer will be, first it has to travel root node. Your root node is minus. After minus, it has to visit right subtree. So this is the right subtree. So right subtree is plus. Okay, in the right subtree again you have a child. So that also you have to make a note. So all the right subtree has been over. Now it comes to left hand side. Left hand side star is there. Okay, after that you have to travel to the right subtree. Okay, right subtree is 7. Okay, after getting 7, what you have to do? You have to travel a left subtree, 6. So from this we can able to analyze the answer. So minus plus 1. So minus plus 1. So we'll be having a chance of getting answer either it is B or C. From the sequence 6 and 7. Sorry, from the sequence 7 and 6. Okay, so this C will be the correct answer. Let's finish the question here. Okay, after once we complete this right hand side, again we go here. After moving here, what symbol here we are having? A power symbol, and again it has to travel right hand side. When all the right hand side has been over, you have to look into left hand side. Okay, minus. Once the left hand side you got, again you go for right hand side. You have to visit right hand side, 5. After finishing 5, you have to come back to the left side node, star. After star, again you have to visit right hand side of the node, 4. And again after right hand side you are going to look into the left hand side of the node. So the sequence is plus, minus, plus 1, star. So this is the sequence. So I think C is the correct answer. So these are all some of the gate questions we have discussed related to tree. So from this we will just wind up the session. So we'll continue in the next gate class. Thank you.